So hello students, welcome once again to our YouTube channel Turito and our series TEJAS. So those were the questions which you would have got as posed. So let's solve the first one. Of course, we'll be solving first one today. And the first question is its integral of x plus 2. So the integral is integral of x plus 2, and I believe you all would have definitely tried this question. See, the target here, as I said in the previous videos also, the target is to cover the different type of questions also in a topic. Okay, so we have already solved 2-3 questions on integration, so that's the next question. So let's see what's new in this, if there is anything new. So definitely you would have got something new if you would have tried it and got the answer or the solution. See, the purpose again of this question is that to tell you the special tricks. So there's a form which you should keep in your mind, that if in denominator there is a combination of a quadratic expression and square root of linear expression. So whatever you have in numerator, let's not consider it right now. If you have a combination of a quadratic expression in denominator along with a square root of linear term, so the first thing you should try is, let us try to replace the linear term by some variable square so as to get rid of square root symbol in the denominators. That's the first thing you should always try. So take this statement as a general statement for such type of situation, and even if you have a cubic expression also, then also you should try this, that if you have square root in denominator over a linear expression, try to replace that linear expression by t square, p square, whatever variable you want to choose, you may choose. Okay, and then if you get the answer, it's well and good. Don't, then we can think something new depending on the question, but here it will work, I know it, because we have already solved this question. Okay, so now let's of course we need to replace dx also, so differentiating both the sides we get 2t dt. Now let's replace wherever we have x by t. Okay, so x is t square minus 1, so therefore the integral I is, so it will be t square plus 1 dt. Okay, and then we have, of course, 2t will be in the denominator, so 1 by 2 we have t, and this can be written as, see, this expression, look at this. So can we write it as x plus 1 whole square plus x plus 2. Okay, so that we can directly replace x plus 1 by t square. So this is nothing but t square plus t, rather t raised power 4, I am sorry, because x plus 1 is not t, it's t square t raised power 4 plus t square plus 1 into, so it's t here and it's root of t square, which is nothing but t, that gets cancelled. Okay, so now what do we get finally? In terms of t we have 1 by 2 times, okay, rather tx is, I am sorry, dx is 2t dt, so it's not in the denominator half, it should be, we should have 2 in the numerator. So it's 2 times t square plus 1 over t raised to the power 4 plus t square plus 1 dt. Now that's another form. That's another special case, special form here, bachcho. So in the same question, we got 2 different cases, 2 different forms, 2 special cases, 2 special methods. Okay, so first one was this one where I said, if you have anything within square root of a linear expression in denominator, let us replace that linear expression by t square. Now the second one, see, the special thing regarding the second case is the denominator. If in the denominator you have a biquadratic with only even degree terms, so we have just 3 possibilities, t raised power 4, t square and the constant term, which is the case here. Okay, in that case we divide both numerator and denominator by t square. Now you may say, what we have in numerator? Normally in numerator either you will have a constant or you will have a quadratic term or you will have their combination. I am repeating, normally to solve such integral in numerator you will either have a constant or a quadratic term. Quadratic means second degree term, or their combination. That's the normal case is. Okay, so again we'll get something unusual, so that that will depend on the form of the integral, that will take up then and there only. So now let's come back to the method. So what I said, divide both numerator and denominator by t square. So what do we get? When you divide a numerator by t square, we get here 1 plus 1 by t square Okay, dt is in the numerator, and in denominator we get t square by 1 by t square plus 1. Now there is something very special related to this expression, which is t square plus 1 by t square. So t square plus 1 by t square can be written in terms of a perfect square in two form. One is t plus 1 by 2 whole square minus 2, and another one is t minus 1 by t whole square plus 2. Which one to choose depends on the numerator, because that comes from the method of substitution. So under method of substitution, what we always try to replace one expression by a variable such that its derivative we get along with the derivative of that expression. Okay, so here it is 1 plus 1 by t square. Now this is derivative of this term bachcho. So that means I will write my integral as 2 times 1 plus 1 by t square dt over t minus 1 by t whole square plus 2 plus 1 is plus 3. Now I will say let us replace t minus 1 by t by z. Its derivative is dt times, I wrote it earlier, I shouldn't have, but okay, it's okay, dz. So that means I will be replacing this entire term by dz. So hence we got the standard form 2 dz upon z square plus 3. Now that's in the form of, if I am not wrong, 2 by root 3 tan inverse of z by root 3 bachcho, isn't that? So that you can have, because that's a standard form of integral dx upon x square plus a square form. Okay, so yeah, it's 1 by a, that you can check bachcho. Okay, 1 by a tan inverse of x by a, that you can check. So according to me that should be the answer. And now you will replace z in terms of t minus 1 by t, and then t by root of x plus 1 here bachcho. Okay, so that's what you need to do, and then you can definitely match with this statement. That's the statement which you have to prove. That means, see, that is correct. 2 by root 3 we got. Okay, 2 by root 3 we got. Okay, so that was the question for today, and I think those two special methods, special tricks, special substitution, special form, you won't forget. Now wherever you come across, you can use these methods, those tricks, those substitution bachcho.